Okay. Can you hear me? Okay. So just to change the ugly cow to something nicer. Okay, so hi, my name is Svätopluk Hanzel. You can call me Bob. I work at Modern TV or sledovanitv, and today I would like to tell you something about WebAssembly. How many of you know WebAssembly? Hands up. Okay, so very, very few. Okay, a couple more. Have you actually tried to write something in it? Some to-do app, something really simple? No? Nobody at all. Okay, that's good because because disclaimer, I'm not an expert. WebAssembly is just something I enjoyed playing with in my spare time last month or maybe few weeks more. And the reason why I started to playing with it is that recently Go 1.11 came out, was released, and this version was the first to come with an experimental module, Cisco/JavaScript. But I will talk about it later. So okay, first something about me. Why I think that WebAssembly is really interesting. I'm a student at Brno University of Technology at Faculty of Information Technology. As I said, I work as Backend Developer, but I was working as a full stack developer for 3 or 4 years before that. So I really got in touch with both backend technologies and front-end technologies. Usually the front-end was written in JavaScript, which is kind of the main rival of WebAssembly, or rival. We will talk about it later. So for me, as a full-stack developer or somebody with a full-stack developing experience, this is like really exciting new technology. I think everybody should try it. Maybe it's kind of like a new revolution. I don't know. Okay, so for the beginning, a few history notes. On this image, you can see the first website in the world. It is still accessible on this page, info.cern.ch. As you can see, there's not much to it. It's just slightly formatted text with a couple of links. Really nothing special. So, what's missing to that site? You know, it's just text. You cannot compare it to today's websites, web applications. So the key component missing is interactivity. The website that I showed was published in 1991, and just a couple of years later, developers were trying new technologies to bring some kind of interactivity, some computation to the web environment. These are just a few examples. Java, ActiveX, and Flash, they are basically all dead on today's web. The basic reason, also all of them have in common, is that they weren't really in the web. They were like something besides the web. There was the web page structure, the DOM, and something running beside it. Java was running in a virtual machine with basically no connection to DOM, no manipulation. Flash was the same. ActiveX, I actually haven't worked with Java or ActiveX. They were kind of before my time. But I worked with Flash, and it was like real pain. You either had a whole site in Flash, or you could just run few simple things in it, but you couldn't manipulate the DOM or nothing. So yeah. Also these were all kind of slowish. Then came JavaScript, which was famously, or no, not really, but the legend is that it was built in a 10-day hackathon. But it's not true, obviously. Some predecessor was built in a 10-day hackathon, which was called, I think, Mocha or something like that. But of course, there was a lot of work to get to where JavaScript is today. Okay, so we are moving to WebAssembly. What is WebAssembly? This is some kind of definition you can find on webassembly.org. WebAssembly is a binary instruction format for a stack-based virtual machine. What? I don't know. If I just read that, I wouldn't care about it anymore. So what really is WebAssembly? It is a virtual machine for web browsers. Well, I will not get to that later. So, does anyone know what is a stack machine? Okay, 1%. Basically, WebAssembly is a binary format which using the stack machine can be I can't find the English word. Executed, maybe, yeah. So it's binary format, but for the sake of debugging, it has also a textual representation. So you can always transform it to textual representation and see what's happening in the web browser. It is safe. It is because it is implemented as a virtual machine in the browser. It's sandboxed, and you don't have to worry about security. Actually, it can be implemented in the JavaScript virtual machine, so there's no need to create a new virtual machine in the web browser. But it is a lot faster. I think I've got some benchmark images later on. It is a lot faster. It comes with a near native performance, so you can really boost up your applications. It integrates with DOM. You can directly manipulate DOM from WebAssembly. It might not be the nicest manipulation, but it's definitely working. You can do pretty much anything that JavaScript can, and it has JavaScript bindings, so you can use any of the existing functionality already implemented in the browser and just call those functions. For example, I mean, create element when you call it on a document, or I don't know. Yeah, you get the idea. you can call JavaScript functions. You can define WebAssembly modules as you can import WebAssembly modules into JavaScript. So it integrates with JavaScript really well. Yeah, okay. Looks like my slides can get messed up. Okay, never mind. So what can I do in WebAssembly? Pretty much anything. These two links are, I think they are here. Yeah. The first link is this application. It's a game. It's written for Unreal Engine. It's actually a demo from Mozilla, and you can see that it works really well. You can walk in there, anything. I will give you the link so you can play it later on. Okay. The second one is a Game Boy demo, but I will not get to that. So why should you use WebAssembly? The simplest answer is performance. Because, as I said, it has near native performance. It outranks JavaScript in the most computation, like hard work. I don't know how to say it. So that's the most important thing. But it can be a lot smaller than JavaScript, and therefore the load time is faster. But many companies decided to use WebAssembly because they had some code written in C or C++, which were which are the languages WebAssembly is targeted to in the first steps. So they can share their code base. They don't have to rewrite the same thing for web. They don't have to rewrite the same functions into JavaScript. They can just use the same C code. Okay, so here's an image from an article, Performance Testing WebAssembly versus JavaScript. As you can see, these two top are JavaScript functions or JavaScript implementations, and C outranks them like pretty much in everything. But there are some differences or some things to keep in mind. JavaScript is faster for small arrays. These were some computations on large arrays. This is 1,000 times 1,000 items. So their C is really fast, but JavaScript outranks them in arrays like 120 to 120 items. So you should obviously like take that into account. Can I use it? I don't know. Can I? Just lame joke. But the answer is yes, you can. Since late fourth quarter last year, all 4 major browsers implemented WebAssembly. So Firefox, Chrome, Safari, Edge, Opera, pretty much everything supports WebAssembly. You don't have to like these few boxes marked with the flags and the numbers means that you had to enable it manually, but you don't have to anymore. It's enabled by default. Actually, a lot of companies use it. From the examples I was looking for when I was preparing for this presentation, for example, AutoCAD is using WebAssembly, which is a huge company, and they believe in WebAssembly, and it's working for them. Does this mean dev to JavaScript? No. From the beginning, WebAssembly was designed to cooperate with JavaScript. For example, it is the most sensible usage of WebAssembly is to use it for the hard work and let JavaScript handle the UI, the UI. It's not good for much. So basically, you would want to still use your React, Angular, anything you want to manage your UI, but let WebAssembly handle the hard work since it's faster. Okay, this is a Golang Meetup, so let's look at WebAssembly in Go. Does anybody know this project, Go4JS? Okay, pretty much the same people. If you don't know it, you should check it out. It's really interesting. It was created in 2015, and it was created by this guy, Nilans. I don't know his real name, but Nilans is nice to remember, so I just kept Nilans there. It compiles Go to JavaScript. So this is not a WebAssembly project, but it enabled you to, or allowed you to write web applications in Go since 2015, when there was no support for WebAssembly. Yeah, but it's not WebAssembly. WebAssembly was added to the main branch just recently, or the main release of Go just recently, as I said. But it was also created by Nilans. He forked Go source and edit the functionality. Well, okay. It allows us to compile Go to WebAssembly, and it edit this module is called /js, which handles all the DOM manipulation, communication. I don't know, JavaScript callbacks. You can set new variables with it, and pretty much everything. It's really small but powerful. Although maybe not the prettiest you could see. So the last point is shows how to compile for WebAssembly. It's really easy. If you ever use cross compiling with Go, you just set Go as and Go are variables, and it just builds like that. Yeah, maybe you should have specified the output as main.wasm, but it is not a big deal. Okay, I've got a couple of examples just to see what you can do with it. So I will just sit down for a bit. Okay. These are just some I made while preparing for the presentation. I think I should like this.
Can you guys see it?
I can make it larger.
Yeah, it would be great.
Okay. What's that? Okay, nothing. So, hello world. Well, that's the basic file you want to create. Or I can't take it right now. So this is a very simple program. It should just print hello world and then hello Bob. So if I go to this directory and just run go run main.go, it will indeed print out those two words. But what if I want to run it in the web browser? Well, I created a make-file, so it would be easier to run it. It basically just compiles the file, the main.go file, using the cross compiling I showed earlier, and it outputs it as main.wasm in the same directory as it was in before, and then just serves another directory which is called site, in which I have this index.html file. It's also really simple, nothing special in there, but there is this special file, which is called wasm.exec. You can actually copy this from your Go root. It's there with the newest release. And okay, so what it does? I can actually go here. It defines class Go. Which has some definitions. Your WebAssembly code probably will want to use. They are basically these. We don't have to go into detail what they do. It's not really important. The important thing is to know that you have to include this JavaScript file into your index.html, and then basically just run this code which fetches the main.wasm file and uses the newly initiated object for some bootstrapping, and runs it. That's all. Okay, so make run hello world. Okay. I will go to this site, and you can. Yeah, now you can see. I don't know what was this, but it doesn't matter. you can see that it wrote out to console hello world and hello bot. I didn't have to use anything special. I didn't have to use any JavaScript functions, nothing at all. I just wrote out to standard output, which in the WebAssembly architecture is considered the console output. Okay. This is kind of stupid example. I started to write something. I called it framework, but it's not really a framework yet. It's just the wrapper around a couple of things, so you can get easier access. But we can actually look into that as well. Okay. Because it's really nice how you can to see how you can get JavaScript functions, or how you can use JavaScript in this. So in here I basically this JS is this module. It has a method global, or function global, which gets you the global JavaScript context, which is usually document or window, and on that you can call a console. This is actually equivalent to window.console. It's the same, and it returns you the JavaScript object without any typings or anything like that. It's just some value, but it is still pretty usable. And you can then use the call method to call the log function and pass message as its argument. This line is actually equivalent to something like console.log MSBR. So really nothing interesting or special. Okay. You can use any features of Go. This is some example with channels. You can use those. You can use logs. Anything really. What I was really upset about that you can't yet use OpenGL or really any CGO in your projects or in that. So this won't compile, for example. This is some example I copied from some OpenGL code tutorial, but it won't compile for WebAssembly because it uses CGO. Okay, I mean I've got some benchmarks also copied from benchmark game, if you know it, and some callbacks, which actually this is just a simple example to which shows how to define a global variable, which in this case is a function. But that's all. Okay, so yeah, I think we don't have to go through all those examples. Okay, so that's basically that's all from me. This should say questions if anybody has some questions. Anybody? Nobody? Okay.
Do you think it's usable yet, like in production or?
I started writing. Well, there are already some DOM manipulation libraries for Go, so they make it pretty usable, but it's not like React. You know, it's a lot more work. You always have to call method. You know, it's a lot more complex. So not really. It's fine for experimenting, and it's nice for writing in some other language than Go, because for now you can't compile or link statically when you are compiling for WebAssembly in Go. So the binaries are like 2 to 5 megabytes at the very least, and if you had some logic in it, it would be 20 megabytes, and you know, load the website with the 20 megabytes logic. It's not really nice. But if you good to use C or C++, that would be nice.
You said that we can use basically anything in Go. So does that include like network calls and?
Yeah. You can actually just create a new request, pass it a few parameters, and it maps to the web browser's API. It's a bit slower, but you can definitely use it.
So it's just limited to HTTP, or you can make like raw network requests, or?
I haven't tried that. I was trying to make a gRPC example work, but I couldn't. But you can definitely use gRPC. I saw some examples. You can find them online somewhere. I think most functions will be fine, or most sockets connections.
Can I open port, for example?
Like for listening?
Yeah.
I don't think you could connect to it because it's in a virtual machine in the browser sandbox. You couldn't connect to it.
And what about the file system? Do you have like some kind of a virtual storage in the browser?
You can access local storage and session storage in browser, but you cannot obviously access the file system of the computer you are running on.
Yeah.
Just through web browser's API. So like file open, like that.
Okay. So if I call like OS open in the WebAssembly,
probably panic. I don't know. But I tried the file open examples, and they will work. Like when you are using web browser's API. Yeah.
And that another example, was it actually compiled for WebStack, or was it like default exe file which is just run?
No, that's actually compiled using mscripton for web. Okay, so you can I think at least you could compile it and run on desktop your PC, but this was compiled specifically for WebAssembly.
Yeah, okay, thank you.
Okay, anyone else? If not, I'll just give you the mic.
All right, thank you again, Svätopluk. Right now, I want to invite Maruška from sledovanitv here to give us more information about what we can win, or what you can win, guys, and about sledovanitv.